Welcome to Module 204C on timers and smart relays. In this module, we're going to be looking at two different objectives. First, we're going to look at basic timers and the basic functions that go along with those, and then we're going to compare those to our smart relays. We're going to see where the smart relays can be used and what kind of added functionality they offer us. Automation is a way of life. Timers and smart relays are a common used tool to achieve automation in our industry, and we see it on a daily basis even though we don't even know that they're there. As technology advances, automation has made it into our lives more and more. So here's the starting point of where it all began by looking at basic timers. In this objective, we're going to be looking at three basic types of timers which will provide a basic automation function. The first one is a spring-wound interval timer, commonly seen as a wall switch. It has a timed on function, and as you turn the dial to set the time, it tightens the spring on the inside of the unit. As the spring unwinds the clock mechanism, it turns off the circuit. This is typically used for saunas and lights, and they're cheap, but not terribly accurate. The next basic type of automation that we have are mechanical and electronic time switches. These are normally used for things like security lighting, lawn sprinklers, and parking receptacles, and things of the sort, and they can turn circuits both on and off. The mechanical time switches use small electrically driven clock motors in order to activate the on-off functions of the timer. However, these mechanical timers are not very accurate. The electronic timers are very accurate and can even be set for sunup and sundown times in your area. The third type of basic automation that we can have are timing relays, and there's a number of different styles that we can use with this as well. We have pneumatic timing relays, which are air controlled, and we have dashpot style, which is oil filled. Both these types are based on the slow release of either air or oil between two chambers. If we wish to change the amount of time it takes to set the timer, then we simply change the orifice size, and that will allow more or less oil or air between the two chambers. We can also have electronic timers, which are more reliable, versatile, and a lot more accurate. All timing relays are built with basic functions in mind. The first basic function that we will talk about is time delay on energization. With this type of function, when the timer gets a signal or the coil is energized, it starts the timer at that point. As the time continues on, once the time has elapsed, it then changes the state of the contacts inside the relay. So the time delay on energization means that the contacts are going to be delayed for a certain amount of time after the system is energized. The second basic function I have for my timing relays is called time delay on de-energization. With this type of function, my timing relay acts like a normal relay upon energization, where it will change the status of the contacts immediately. After the coil is de-energized, that's when it starts the clock. The clock will run until the certain time has elapsed, and after that time has elapsed, then it will allow the contacts to go back to their original position. So time delay on de-energization does not start counting the clock until the coil loses power. Both these timing functions have their particular uses that you can design them for. An example of TDOE is for a two-stage motor control, where you'd have one motor start up with instantaneous contacts, and after a certain amount of time, we would have a second stage motor start up. For TDOD, we would have a delayed off function, which could be used for things like purging fans for certain systems, or for grain mills to evacuate any leftover seed. Both these types of controls can have instantaneous contacts, which means they have a set of contacts that are not controlled by the time delay function. Rather, they will change state upon coil energization and de-energization, the same as a normal relay would. A step up from our basic timing relays is our multifunction timers, and they offer even more options for different types of timing circuits. In addition to my basic functions of TDOE and TDOT timing, I can also have other timing functions such as interval timing. With interval timing, my contacts change when the coil is powered, and at that exact same time, my timer starts to count down. When my timer countdown is complete, the contacts will change back to their original position, regardless of whether or not the coil is still powered. Some timing functions, like the one-shot timing, require full-time power to the coil in order to power the circuit board that's inside the timer. With this type of timing function, we require to have a start signal that comes to a specific terminal on the timer itself. Once the start signal is received, that is when the time period starts and the contacts change at that point. After the time period elapses, then my contacts go back to its original state. A good example of where I would use this type of circuit is with step lighting inside housing. Another function that requires full-time power to the coil is my repeat cycle timing. My repeat cycle timing can either be set up to work with a start signal, such as my one-shot timing, or it can just be activated when the coil is energized. With this type of timer, it will change its function based on a timed amount. Some timers will allow you to have a different timed amount for your on as well as your off functions. However, most of the simpler ones will just have one set time, and that is the time elapsed for both the on and off. And we would see this on the side of the road with traffic cones that have a light on top that blinks.
We're going to take a look at timing relays now. I have two different varieties of timing relays that you'll likely see inside the field. So these are the most common two that I've seen anyway. So with this type of relay here, I do have a pinout diagram on the side here. It tells me where all the pins are connected. I can see on each side I have two different circuits, one here, and each one of those has a common terminal. This one here is linked to number 8, this one here is linked to number 1, and each one of these has a normally open and a normally closed associated with it. So I have one input, two outputs. This is single pole double throw, and this side here is also a single pole double throw. Down here where it says source, that is where I'm going to connect to my coil. So this is where I'm going to connect into my control circuit, and this is going to go between pins 2 and 7 on this particular unit. This unit is removable from a base, so my base here would have all my pinouts here, and that's related to the pins actually on the inside. And there's my pins. This is keyed, so there is a little bit sticking up there, and that is going to associate itself with the keyhole on the actual base itself as well. On the side here, we do have a wiring diagram. So I can see my coil here, and also has the pin numbers. I can see my inputs and my outputs here as well for my two different circuits that I can hold on here. And now this is all my information as far as what the voltage is for my coil, as well as what the voltage and current rating is on my contacts. So it's important that I do not exceed these so I don't blow this up. As far as this is concerned, this is how I do my adjustments on here. So the mode itself can be switched. So right up here in this corner, I don't know if you can see that, but it says A right now. I can change that over to B, C, H. It does have a number of different functions that you would find in the paperwork that you can use. We also can change our time settings by adjusting these dials here. So that is going to be minutes, and I can change it down here to be seconds or hours as well. So there's a number of different adjustments I can make on this. So I can change my mode here. I can change my time frame here between seconds, minutes, and hours. And I can change my settings here to give me a different variable here. So right now, this is set between 0 and 12 hours. I can make this between 0 and 12 minutes, or I can change that value in order to be a different number altogether, such as right now, I'm between 0 and 30 hours. So I can change exactly what I want. I can set this up any way I want. The thing with this one is that you have to have the paperwork in order to know what the different modes are, so make sure you're reading the paperwork properly. With this one, this is a Schneider one. I have my wiring diagram here. It also serves as my pinout diagram. And here I have all the different functions that I have. So this is where it becomes important for you guys to pay attention to your module. So you should be able to identify what A is. You should be able to identify what H is, or B is, or DI, or AC, or whatever the case is. You should know that that one there, for example, is time delay on energization if you look through your modules properly. To select which mode that we have, we open up this little cover on the front. This is our selection for our mode. We get in here with our tool and we can select whichever mode we want, such as A, that is selecting time delay on energization. We can adjust our time with this dial here. And the very top dial up here is our variance. We can set this for all sorts of different multipliers. So where my time dial here is from 0 to 10, these are going to be multipliers. So if I have this set at 1 second, If I have that one set at 1 second and I have that one set at 10, then that means the total timeout will be 10 seconds. I can change that to 7. Now the total timeout is going to be 7 seconds, and so on and so forth. So I adjust my time here, I fine tune my time here, and I choose my mode here.
You've reached the end of objective number 1. Make sure you're going through this objective to understand what the different timing functions of my basic relays are, so you can identify which ones are which if you're to look at a diagram. Pay attention to time delay on energization and understand the difference between that and the time delay on de-energization. When you're ready, continue on to objective 2.